what can we say about it? So the Rust SDK started something like 2.5 months ago. To be fair, it was already there was a work in progress repo since like basically the start of the project. But yeah, like we finalized and we made something concrete in the last 2.5 months, I would say. And this really started from when we started building a unique library where we implement all the fundamental aspects of the SDKs called the SDK shared core, which I'm going to talk about this in a second. So I'm going to start as usual from our CLI. We have this tool called Restate examples, where you basically can download one of our examples, which contains some templates that are useful to get started. So I'm going to go to Rust. And immediately right now you see we have two hello words. One is just a plain hello word. The other one is an hello word that is integrated with Shuttle RS, which is a popular platform for deploying Rust applications. We're going to go with the basic hello word. And then I'm, all right, I use IntelliJ IDEA. So yeah, it's going to take some time. Before looking at the code, maybe let's quickly look at the dependencies. So the Rust SDK essentially just needs a Tokyo. And we add the tracing subscriber to bring log lines to terminal. Tokyo is not mandatory. If you don't want to use it, you can replace it with your own async library. Also, Hyper per se is not mandatory. Like the SDK is built in different layers, and you can pick and choose what layer you want. But the battery packed in your version just uses Tokyo and Hyper. And greater example, again, if you're familiar with Restate already a bit, you probably recognize this. So we have the definition of the service and its handlers. And in your Rust, we do this using the just traits. Then we implement this trait, as you would do with any other Rust trait. And then in the main, we serve the implementation of the trait using that HTTP server, and we start it. So let me just show you that this actually works. So it's commands, it's graphic, sometimes it's Rust. And yeah, we're going to start a state server, another terminal, and then run proprietor registration. What you see here is usual Restate Rust stuff. So we prepared a tracing subscriber for bringing log lines to terminal. Then this HTTP server is something we provided. It's essentially just a facade or Hyper to start the server. And we deploy this return implementation on 9080. So there you go. We registered the Restate service. And here we are. We can look at Restate line and services list. Yes, so we have the service registered. And yes, this is pretty much the good example. Not much to say here. So the Rust SDK, the way it works again is that you need to define the trait, where you define the service, and then you define the handlers. And as you may imagine, this macro is really where a good part of the magic happens. And it does all the wiring internally to make sure that discovery will correctly discover this greeter service. And also when invoking it, it will correctly invoke the right handlers. And the service is to create just a plain service. Then you have virtual object. Sorry, it's called object. And this one is to create virtual objects. And then we have workflow. And when you have object, you also have the annotation shared to define shared handlers. Now, you see here that this trait might sound a little bit strange. What's happening around here is that we define input and then we define output. And the result is just a little alias for this result here, where terminal error comes from that Restate SDK. I'm going to explain this in a second. So every handler has input and output. This input and output are the trait to serialize input and output. You can just use the server library for doing a serialization. You can also plug in other serialization formats if you want. You can use protobuf if that's the tool of your choice. And you can also not have any input or just remove the output, and this also is going to work for you. Every handler needs to have as a return type a result where the error is either terminal error or is any error, for example, any error. I don't have it now imported, but you can have this, or Andrew error. And this one is another type from the Restate SDK. So from the other SDKs, again, I assume you probably already noticed. If not, essentially in Restate, we distinguish between terminal and triable errors. Terminal errors are errors that essentially are a result of the handler. So when you throw it, the handler won't be returned, it will just fail with that error. While non-retriable errors, which are usually everything that is not a terminal error, will be returned by Restate. And so in Rust, present this terminal error with the terminal error struct, and every other error will just count as a retriable error. So for example, if inside here you do some operation with request, which again I don't have it here, like you do request get, and then you do question mark, this one will automatically get propagated as retriable error. Okay, now maybe let's actually very quick try to call this. So it's curl create binary.
Maybe a small question. So you return there either terminal error or handler error. What is handler error?
Handler error is just essentially the proper type for containing either a terminal error or any other error. Handler error, effectively, you can clearly see this. It's either a triable or terminal. And this is just essentially some into from magic to make sure that the question mark will just work as expected.
Okay.
So,
yeah.
And okay, let's try to call this. Works. And now let's try to start using the context. So the context, as usual, we have this context object, struct or interface, where you actually access all the Restate features. So the Rust SDK is no different in this sense. And here, context dot, you see you have a lot of methods that expose all the different Restate features. For example, you can have a sleep or 10 seconds, and just wait it, and this is going to work fine. So we just rerun this. All right. Okay. Oh, yeah, sorry. Error. Of course, because this was because I made this as an object. Of course, now Restate was complaining that, like the compiler was complaining, this should be object context. So let's run this and let's make this an object. Fine. We need to register the service again because we changed the type. Yes, and then let's call a creator. Using Francesco, this is gonna sleep for 10 seconds. 8, 9, 10, 9, 10. Okay, great. And we got the sleep working. And so that's one example. And now let's maybe try to do a counter on this greater so that every time it will tell you how many times you greeted the person. So let's say we want to do count. We need to define, first of all, the name or the key of the state. So let's say count. And then we do context get count. And count equal. This is U16, for example. Great. And here we go. Why is complaining? Because of course this is optional. So this is unwrapped default. Okay. And then we do count +1. And then we do context.set. So we update the counter, count, and then greeting, and then we just print the greeting. And here we go. So start this again. We don't have watch tools. At least I'm not aware of any watch tools in Rust. Something like more Node watch or anything. If you guys know it, drop it in the chat. It'd be pretty useful for this type of demos. Yes, and then now we run this again. So now we should get a new message. Go to Francesco for the first time, second time, third time, and so on and so forth. So this is how you access state and use state operations. Now maybe let's look at how to call handlers between each other. So let's say now this object gets a new handler that is, let's say, just sleep. So it will sleep and then returns result of this and infallible. Actually,
we have a question in the chat from what does ctx.sleep do differently compared to Tokyo.sleep, or are they both the same?
No, so this is the durable sleep from Restate. So the durable sleep from Restate will persist the timer, and it will essentially be kept in case of a failure. So let's say you needed to sleep for 1 year. Of course, you don't want to keep the connection alive, nor maybe you want to keep the process alive for 1 year, but you want to remember that you are sleeping for 1 year. And this is what the context sleep, like the Restate durable sleep, gives to you compared to the Tokyo sleep. Does that answer the question?
I think so, yes.
Okay.
Another question, does auto-scale to 0 work with durable sleep?
Yes, of course it does. Yeah, of course it does, because Restate behind the hood knows that the execution is blocked on waiting that event, which is the sleep. So when the Restate scales to 0, records internally, I'm waiting for the sleep to happen. And then when the sleep happens, it will resume the execution from the point where it left.
So it resumes just after the sleep, even if the process is killed? Yes, exactly. So indeed, what happens when you do ctx.sleep is basically Restate writes down how long it needs to sleep and at what moment it needs to wake the service up. And if you, for example, run on AWS Lambda or serverless infrastructure, what will happen is your Lambda function will go away, will scale to 0. And when Restate sees, it's time to wake this service up, it will wake it up, send over the progress from the last time, and fast forward the execution to the point after the sleep. So one other question, does this SDK support WASM as a target?
So yeah, this needs to be teared down a bit because it's a complex one. So as it is, the battery packed version, it doesn't, simply because it has Tokyo, it has a Hyper, and like those, they don't, like, I'm not sure if Tokyo right now works on WASI target. I'm not aware of this, to be honest. But we compile to WASM the internal library that implements the protocol, which is essentially the core part of this library. So like the Rust SDK is built on top of the SDK shared core, which is the library I mentioned before. And this one not only compiles to WebAssembler, but right now we actually replaced the core code of the TypeScript SDK with this library. So right now, when you download the TypeScript SDK, it actually runs this WebAssembly module under the hood. So this part we know for sure it works on WebAssembly. It's thoroughly tested and everything. But the Rust SDK itself, we didn't really test this. So in theory, it should work. There's no reason why it shouldn't. And the SDK, again, is built in modules. So if you don't bring in Hyper, and if you don't bring in Tokyo, and I don't know if you want to use WASM Edge, one of those platforms where they give you the HTTP server API, essentially, then I see no reason why it shouldn't work. Actually, I'm curious, do you have any specific idea of some WebAssembly platform where you would like to run this, or you would like to see it running?
Yeah, so I was exploring different platforms to run functions and handlers at the edge because making an app globally available is quite important to me. And I went with Deno, but I really wanted to get something that worked with Rust. And I was exploring Wasmer.io. So they support running WebAssembly binaries and HTTP servers as long as they compile to WASM WASI32. And I was considering using Restate Rust, but I haven't got into trying it yet. So as I know that Axum supports WASM. So if I could run an Axum server and hook in the Restate SDK, maybe I'll get something that works, and then I can deploy it on wasmer.io.
Axum under the hood uses Hyper and Tokyo, which is the same technology that is used in the Rust SDK. So maybe actually just
Try it
works.
and see.
to maybe it just works. I don't know. Like again, I haven't tried that. Maybe it's worth trying at some point. But definitely right now, if you use the TypeScript SDK, effectively you're getting a 50% Rust SDK right now. So because it shares the same code base.
Thank you.
Okay, one maybe final aspect I wanted to show of the API before wrapping this up. I wanted to show how the like handler-to-handler communication works. You see here we made this greet, and now let's say we want to call from greet, we want to call the sleep method. So in order to do so, we are gonna do context.object client, and we use the turbofish notation to specify which type we want of client. In this case, the greeter client. I'm just gonna come up with a key dot sleep, and then call. And this one effectively is the way to call the other services. You can call, you can do a send, you can also do a send with delay. And this is
one question just for clarification. The dot sleep here is the name of the function you are calling, right?
It's dot sleep is the name of the function. Yeah. It's I should have chosen a better name. Yeah. And this is how you use a client, how you call different services. And you have workflow client for workflows, and then you have service client for calling other services. And then if you want to explore more, you can go here. So we are aiming to actually have some proper docs in the Rust official documentation system, because that's how people seem to like it. So we are trying to compile a proper documentation here that will look like the manual that we have for TypeScript and all the other SDKs. So right now it's not complete yet, and it's still a work in progress. But if you go here in context, you see all the different traits, and you see for each different trait that explains each single individual thing what it does. So then you can also see in the macro mutation here, it tells you all the different things that you can do with the macro. You got the types accepted or not, to get everything up and running, and so on and so forth. So the documentation is still a work in progress, but for now, if you need anything, just refer to the documentation on docs.rs. And that's where you'll find pretty much everything that is documented so far. I wanted to spend a couple of minutes just maybe two things I wanted to say. So first of all, the Rust SDK, as the Python SDK, and as the Golang SDK are 0.x. But 0.x for us means that if the SDK is stable, is tested, it's actually thoroughly tested. We have different type of testing, simple end-to-end tests, but we also have fuzzy testing, so it's really thoroughly tested. And we also guarantee compatibility with what is written in the storage. So this part does not change. But we keep the SDKs in 0.x because we still want to reserve the right to change some APIs, because like we are still essentially exploring it is the best way to expose Restate features in these languages. So that's really the only reason why you see this as being 0.x. But effectively, they are stable and you can use them even in production, no problem. So that's one thing I want to say. The other thing I want to say is the reason why we got so many SDKs in the last months is that we wanted, first of all, to reach more communities. That's a obvious reason. And the way we did it is that we built this library called the SDK Shared Core, which you can just go and use it. It's on the crates.io. And this library essentially implements the core aspects of the SDK. It implements the state machine that interacts with the runtime and implements all the essentially complex orchestration that happens between the two. And then the Rust SDK, the Python SDK, and now the TypeScript SDK too are based on this library. So they just bind it, they are wrapping it internally, and what you get as a user is just the high-level API effectively on top of this library. And eventually, if you feel you want to experiment, you can also build a new SDK based on this library. Right? So we are thinking maybe we do another community meeting where we talk about this a bit more in depth if someone is interested and wants to know more about how an SDK works internally and how one could build an SDK on top of this library.